Boulder and School of Mines took the FE exam. Here we have a bunch of scores, unequal sample sizes. We want to determine if one student population performed better than the other. So we're going to perform the hypothesis test, and we're going to state our conclusion, and we're going to calculate a p-value. I've got this in a file called FE exam data. By the way, this is hypothetical. We've calculated our sample statistics here. Our sample statistics point to a lower-tailed test of mu1 less than mu2. So 1 is going to be UCB, 2 is going to be Colorado School of Mines. I've calculated my sample statistics. I've named a bunch of things. In this case, it appears that our standard deviations are quite different. And again, you're going to learn how to use the F-test to determine if these are equal or not. But I'm going to assume for now that they are unequal variances. For unequal variances, our test statistic is shown here, where we compared to the t-distribution with new degrees of freedom. We got a couple different things that we need to calculate here. I've got my alpha value here. Let's calculate a test statistic. x1 bar minus x2 bar divided by the square root of s1 squared divided by n1 plus s2 squared divided by n2. So our test statistic is negative, just about -2. We have to compare that now to the t-distribution with new degrees of freedom. So I'm just going to say degrees of freedom. I'm going to put in this big ugly mess here. I would definitely recommend spending some time double checking that you've got this inputted correctly. Pretty sure that's correct. So I press enter and we get 14 degrees of freedom. We calculate our T alpha with 14 degrees of freedom, and that's equal to T dot INV. This is a lower tailed test, so I'm just going to do alpha, comma 14. So I click there, and that means our critical point on the T distribution that we have to be below in order to accept the alternate hypothesis is negative 1.76. It appears that our test statistic is less than that. In this case, we accept the alternate, reject the null, and we can claim that University of Colorado Boulder students performed worse than students from Colorado School of Mines. We can also calculate a p-value. A p-value is just the area to the left for a lower-tailed test of our test statistic, t.dist. This is a left-tailed, so I just use t.dist, our test statistic with 14 degrees of freedom, and this is cumulative. And when I press enter, we get a p-value of about 0.033. There is a built-in tool. You can use the data analysis t-test for two sample assuming unequal variances. That's what I'm going to do here. We have our two ranges. I'm going to put in my first one, my second one, a hypothesized mean difference of 0. I'm just going to output this on the same worksheet down here. Press OK. Going to resize this real quick. You see that the degrees of freedom is 14. Our test statistic is exactly the same. Our p-value is exactly the same as this data analysis tool calculated. So hopefully you learned how to compare two populations based upon their sample averages when variances are not known.